Hey guys, welcome back. So today I brought home what used to be a storm responder generator. I haven't done anything to this. This is exactly how I got it, other than bringing it in the garage here. And as you can guess, I'm sure, this engine ran out of oil and it blew the rod. And you can kind of see some of the damage here. So this engine's pretty much done, but we have pretty much everything else that we need to put a generator together, except an engine. Luckily, I just rebuilt this engine and got done testing it today. And this is a good engine. It's a direct replacement for what comes on the storm responder. So there's not a lot to do here. I think the hard work's already been done. Really, we just need to get that engine on this frame, put the power head back on, and see if this thing works. So I pulled the engine mounts off of the blown engine. That's really all I need from this machine at this time. I do need to put a bell housing on the good engine, but I have an extra, so I'm just going to use that with a bit of Loctite and tighten it down to 20 foot-pounds. Power head here on the right is the one that came with this generator, and I have no reason to believe it's bad. I did do a quick ohms test. Everything's fine. So if I was smart, I'd just go with that and not question it. But the one here on the left actually came on a generator that wasn't making power, and it tested fine with the multimeter. All the ohms tests came back fine. No connections to ground, no connections to adjacent coils. For all purposes, that one should be good, but it didn't power up. So, I already published a video on this one. I ended up swapping out the power head, but I didn't want to throw it away because I couldn't prove that it was bad. Anyway, it's been about a month since that video was filmed. And since then, I learned something. The brushes that came on this generator head, the one on the left, were bad. One of the diodes was shorted out, and besides that, they were installed backwards, so any residual magnetism would have been lost by doing that. And I didn't know the brushes were bad at the time. I'd say 80% of the testing I did was with the bad brushes on this power head. At one point, I did swap the brushes out. It still did not power up, but that could have been due to the fact that they were previously installed backwards. And even once I corrected the orientation, the diode was still bad. So I'm not ready to give up on this one yet. And I have since picked up a Megger. So what I'm going to do is do a high voltage ohms test on this stator on the left. And if it tests well, I actually want to install this one and see if it works. And it is the same part, so the rotor, even if the stator ends up being bad, the rotor probably won't have to come off. I can just swap the stators and keep on going. So it'll be minimal effort to give this one a try. So let's get the Megger set up and test it. So this generator has 3 windings. There's 2 main windings, which come out in this outlet. Winding 1, or leg 1, are diagonal from each other, and leg 2, diagonal the other way. So those are the 2 main windings. Also, we have a DPE winding, which goes right to the brushes and bridge rectifier. So all 3 of these windings need to be checked against each other and also to ground to make sure there's no problems. So hopefully you can see this okay. So the way you read this, I mean, it's like any ohms meter. We got 0 ohms over here and infinite ohms on the left. And that's what we want to see when we do these tests. You know, if I click this to say 500 volts and I short the 2 leads together and I crank this, you'll see this meter will shoot over to 0 ohms, which is basically showing that we have a short like that. So that's what we don't want to see when we're testing. Okay, so I got 1 lead in each of the main windings. There should be no connection here. We'll start with 500 volts. And it's infinite resistance. We'll try 1,000. Same thing. So the main windings are not shorted to each other. Now we have a connection on the DPE winding and one of the main windings. We'll try this again. 500 volts. No connection. 1,000 volts. No connection. And now we'll test the other main winding to DPE. That looks good at 500 volts, and that's good at 1,000 volts. So none of the windings are shorted to each other. Now we'll check each winding to ground. Okay, so we got 1 lead here on the main winding. We've got the other lead connected to this clip, which goes to the ground of the stator. We'll try 500 volts. No connection. And 1,000 volts. Infinite. No connection. And now we're on the other main winding. We'll try 500 volts. That's good. And 1,000 volts. That's also good. And now we're on the DPE winding. 500 volts. We're good. And 1,000 volts. So again, this tests well at 1,000 volts. Nothing's cross-connected between windings. Nothing's connected to ground. This stator's good. It should power up. So let me just do the same test real quick with the rotor that came with this stator and make sure that that's also good. And for this one, it's the same test. I've got this lead connected to ground, and then I'll hold this one onto one of the slip rings. Start at 500 volts. And that looks good. Now we'll try 1,000. And we're good. So this power head, the one that I declared dead previously, I don't think is dead. You know, nothing is saying that it should be. I'm pretty sure it was just the brushes, and it may have just lost magnetism because of the way the brushes were installed and the fact that it had a bad diode. So I'm going to go with this head. I want to know 100% if it's dead, but I don't think it is. Just going to clean up the slip rings with a bit of Scotch-Brite while I'm in here. So people always ask me about this bolt. A lot of times people think I don't tighten it or I put it in the wrong way. And the reason for that is that the inner diameter of this bearing is quite a bit larger than the diameter of this bolt. So when you tighten it down, this bolt is usually not centered. And when this thing starts spinning up, you just see a bolt shaking back and forth. And I mean, that's the way they're designed. That's how they all are. But someone did suggest in the comments to build a shoulder using tape. And I've done that the last few times, and it works quite well. Been using electrical tape just to make a shoulder, and then it keeps things centered when you tighten it down. So I'm going to pull this bolt back out, build up that shoulder, and then this thing will be pretty centered. Gonna pull the plug out, get the piston at the bottom of its travel on the compression stroke, and fill that cylinder with rope to lock the engine up. I need to get the rotor torqued to about 25 foot-pounds. Okay, let's hope that's enough. Sometimes if you don't put enough in there, the engine will actually turn over when you're trying to tighten down the rotor. And yeah, that's no good. For this, I'm going to do about 140, maybe 150 inch-pounds. So at this point, you want to pull the engine over and make sure that rotor is not making any contact with that stator. So in order to do that, I have removed the rope. The spark plug's still out, so the engine should pull over nice and free. And it does. So I'm going to finish tightening the stator down. We'll get the electrical squared away, and then I think we're ready to give this thing a try. Remember with these, tab side has to go in. And the red wire goes on top, but this is AC going in, so it shouldn't matter which way it goes. Okay, that's pretty much it. The wiring's done, engine's secure, stator's secure, and we're pretty much ready to go. Just need to get the spark plug in there and we'll be ready for contact. Okay, I kind of have my doubts if this is going to make power without a little bit of help, but let's get it started and see if we get any power output. Gonna bump the speed up a little. Got power. Nice. Okay, this one had me a little bit worried. I thought I was going to have to break out the 12-volt battery and apply voltage directly to the brushes, but after flashing it a few times with the drill, it finally powered up, and then I could see that the engine was running slow. It was at 57 hertz, so I bumped that up to 61.5, loaded it up to 1500 watts, and it did just fine. So I'm going to restart it right now. Just want to make sure the voltage comes on right away and that the residual magnetism issue is sorted out. Okay, good. Power came right on. So I'd say the residual magnetism issues are sorted out. Let's get this inside and finish it up. So I realized I never really explained why the drill brought this generator back to life. So to help explain that, I brought these two rotors up here on the bench. The one on the left is exactly the same rotor that's in this generator. And these are essentially electromagnets. And if you think about it in the simplest terms, a generator is a coil of wire with a magnet spinning in the middle. Now that can be a permanent magnet, but in generators, it's an electromagnet. And when the generator powers down, this turns off. But there is still residual magnetism, and it's just enough to get things going again once you start the generator. A lot of generators too, especially the ones with AVRs, have actually a permanent magnet right there. So those are very unlikely to have problems powering up due to loss of magnetism, but the Briggs one does not have a permanent magnet. It needs that residual magnetism. And there's a few reasons why it can be lost, but in this case, this power head had brushes that were installed backwards. It also had a bad diode. So, the brushes on backwards alone would be enough to basically try to reverse the fields. And what happens is when it gets to that point where it wants to flip, it loses all magnetism and the voltage goes away in the stator, what little there was. And at that point, you have a generator that won't make power. So by connecting the drill to the outlets, holding the trigger and spinning it, it's acting as a little generator, sending power into the stator and creating a bit of magnetism, and some of that transfers over to the rotor. And if you're lucky, it powers up like it did just now. So if that fails, there is another option. You can apply 12 volts to the brushes while it's running, and that'll also power up this electromagnet and restore the residual magnetism. I was just breaking the old engine down. I thought I'd turn the camera on here for the finale. Not much left. I've already cracked all those bolts free as well as the bolts on the head. I guess one thing worthy of note, the bottom bolts here were not that tight. So I'm not saying the oil leaked out, but that is a possibility. Huh. That is a lot of oil in the top end. It smells pretty bad in here. Very charcoaly, but that's not even the right word to describe it. crankshaft also doesn't look too bad, all things considered. There's a close-up look at the cylinder. Not too good, but it doesn't matter anyway. The block has a hole in it. It is trash. And that oil that's in there, that's all that was in there. I didn't drain any of it, but that's why the rod blew and caused all this damage and wear. You know, for a second I thought maybe the piston had survived, but the skirt on this side unfortunately blew out. So that is no good. And as far as the rest of the parts, I'd say the head, the cam, the cover, most likely are good. Potentially the crank could clean up and be within spec. I'm not sure. But, you know, the thing that really surprised me here was how much oil was sitting on top of that piston. But, you know, I know the person selling this had actually thrown this engine basically into the snow, and it was probably sitting sideways or upside down. So most likely that oil wasn't a symptom of what happened. It probably just settled in there through, you know, maybe the valves, the way that it was stored. Anyway, let's finish this thing up. The reason this engine was running slow actually is because I put this in the wrong spot. Usually it should go in hole number 5, but I put it in 4. So I'm going to bend this tab back, move this to where it should be, and we'll have to reset the speed later when we get it back outside. But for now, I'll just leave this cover off to dial in the speed. All right, let's give this thing another try. I did move the spring and bend the tab back, so hopefully I bent it enough to keep it from over-revving. But once it's started, we'll dial in the speed again and just do a final test. Yeah, we gotta speed that up. About 61 hertz, 132 volts. Yep. 125 volts. 59, say 59 hertz. It's good. Okay, good. I think this one's pretty much a wrap. The only thing left to do is just put on this plastic cover, but I don't think I'm gonna show you that because there's really not much to it. Just the 2 bolts here, the 2 nuts on the back, and put the switch in the cover. So not too bad considering this was an engine that previously had run out of oil and blew up, and that generator head I previously declared dead. So both are doing well. You know, this thing is doing exactly what it should. So hope this video helps someone. Thanks for watching.